All right, welcome to DevOps Dispatch. I think round two, since you joined us in Amsterdam. Why don't you introduce yourself and tell us a little about who you
Thanks,
are?
right. Yeah. Gabriele and Bartolini. I'm VP of Cloud Native at EDB. So EDB is a company that develops the open source PostgreSQL database management system. And my mission in my life at the moment is to bring Postgres to Kubernetes.
Yeah.
And that's why also I'm here.
Yeah. I feel like it's been your mission for quite some time now. 4 years.
Now was kind of a vision, blurred vision back then, and now it's becoming more and more crisp and clear.
Has there been like a defining moment for you in those 4 years of like people get it or anything like that? I'm curious.
I think when we open sourced Cloud Native PG.
Okay.
So that's been the moment, and when we started to see that people started to join the Slack channel, and the downloads were going up, the stars were going up.
Yeah.
And now it's basically many people that want to move to go to use Postgres in Kubernetes use our operator.
Yeah.
So,
well, I mean, so stateless and stateful containers, right? In Kubernetes in general. Stateful was definitely something people are a little scared to do on Kubernetes for a little while, right? So you've been doing it for 4 years. And I feel like in that 4 years from, 2019, 2018 to now, we're definitely seeing a lot more, right? So you're part of the data on Kubernetes community as well as we are. And I feel like, they do a really good job at really bringing, some of the educational material about it's okay to do it, just at a basic level, what the difference is. I know we did a panel last in Detroit with you, and now you're an ambassador, right? Tell us more about that.
Yeah, I just became an ambassador, and I'm really happy, even though, I can only speak primarily about Postgres.
Sure.
But still, I think it's important to kind of spread the word that false perception, actually, it was a true perception a few years ago.
Yeah.
Now it's not true anymore.
Yeah, and I feel like even though you're specifically working with Postgres, it translates to a lot of other, a lot of other sort of operators or a lot of other stateful services. A lot of the problems that we talk about, right? Just how you get going.
Storage.
Yeah, it's storage at the end of the day, right?
Well, so, and there's a lot of, for example, collaboration, especially with the storage group in Kubernetes. Storage is the most critical component for a database.
Yeah.
Okay? So it's actually, not a surprise that the first. Actually, you were asking me about the defining moment. I think the defining moment was in September 2019 when we created. When we started the initiative on Kubernetes, we created a bare metal Kubernetes cluster.
Right.
And we ran benchmarks back then.
Right.
And we proved that running stateful workloads in Kubernetes or bare metal was the same thing.
Sure.
So for us, database people, that was an opening moment. And that defined the start of our true initiative in the Kubernetes space for Postgres. Because if it had failed, we would not have moved forward. So we adopted this fail fast approach. So we said, if this is not going the way we think, we stop the project. It's not worth continuing. But it was successful. And then, we said, Kubernetes will improve the storage in time. We do our stuff on the database and we let Kubernetes do the job.
Yeah.
And that's what's happened, because if you think about yesterday, I gave a talk with Michelle Au from Google about disaster recovery of very large databases. Which, if you think, we're not talking about databases. We're talking about very large databases.
Right.
And we rely on the volume snapshot capabilities that Kubernetes has implemented.
Right.
So this is something that outside Kubernetes is not possible.
Mm-hmm.
Okay, so this is, I think, another sign that things are getting better and better over time.
Yeah, and I mean, that's a good point. And I still see that question come up quite often. People asking, what's the performance of me running my database in containers, right? That still fundamentally is something that people don't necessarily understand, that it will be very much similar to a bare metal environment, right? And maybe this is sort of a historical thing where people are coming from running their databases a specific way in virtualized environments and are just, unfamiliar with the unfamiliar, so to speak, right? And they don't know. So I think those types of conversations are very important. And the reality is, your talk about, really large databases, that's a real world use case, right? We've gotten beyond the functionality of it works. And now we have to think about real things like, okay, how do I move this data? How do I protect it? How do I make it available? All these things that are no different than what we used to think about. It's just in a different orchestration environment, right? So I guess, maybe what are the biggest challenges? Let's dive into that a little bit around, working with very, very large databases.
Okay, so our approach has been to delegate all the kind of backup stuff to the CSI drivers.
Yeah.
Okay, so in general, the approach is pretty much the same you have on VMs and bare metal. You need to have a storage that is designed to work with the workload you imagine to have on the database. Okay?
Right.
So Postgres cannot scale horizontally, but it can scale vertically.
Sure.
So if you have powerful machines, you have disks. So now we are also adding table spaces support, so you can scale your I/O on multiple volumes. So all the same principles you adopted in VMs and bare metal, you shift them to Kubernetes. So I think that the main challenges are you need expertise in Kubernetes, and if you don't, you can use a cloud service provider managed solution.
Right.
And then you also need, of course, Postgres skills from day zero. So from when you start planning, so you need to think about the architecture, not only the architecture of the database, but the architecture of your Kubernetes clusters.
Right.
So I actually recently wrote an article on the CNCF blog that recommends architectures for using Postgres.
Yeah.
So that was requested by many users and customers I've been talking to. It's kind of a summary of a year of conversations with customers. Okay. But the message, the idea of talking about very large databases is to give a clear sign that it's not a game. I mean, this is
we can do real things.
Stuff, so if we can move very large databases, you can do pretty much everything. So when it comes to very large databases, an important aspect to consider is the recovery time after a failure.
Sure.
Okay. So yesterday I showed that we were able to recover in 2 minutes a 4.5 terabyte database.
Okay.
So that's quite impressive.
Yeah. Now, I mean, I think multi-cloud, multi-cluster is definitely a theme here, more than it was the previous two shows. So I feel like that kind of use case is very natural fit going on to maybe where people's mindset are. And I think what's curious is how much responsibility does something like Postgres or DB take in that movement of data, and how much does it offload to something like CSI doing snapshots? Like what does that intersection look like?
So I think I was mentioning the architectural part. Okay, so Postgres has a very strong and robust replication system. So the idea is when you use Postgres, you rely on Postgres to synchronize data. In other regions. So we actually have a way, we call them replica clusters.
Mm-hmm.
So and essentially the need is that you've got a primary region, and then you might have a secondary or a tertiary region in your global distributed cluster. But normally only one of them is primary at the same time for that application.
Sure.
Okay? So if you need to write in multiple locations, of course, there are multi-master solutions. EDB has got one that is called Postgres Distributed. I know that Amazon has just is releasing PG Active in that area, but that's kind of a multi-master approach to the problem.
Yeah.
I think I'm still pursuing the vertical scalability opportunities that Postgres provides, because they are much easier, in my opinion, to manage in terms of business continuity.
Right.
So,
And in the world of storage, we also have like this weird delegation of problems, like who's responsible for what, right? Where the operator or even the database itself, right? You said taking advantage of snapshots. Well, you can take a snapshot, but that thing's local or wherever that storage system is, right? Then do you wind up moving that snapshot, or do you rely on sort of the application level, the database level to, move individual?
It can happen so basically the volume snapshots we are now, the idea is to delegate that to the storage class. So ideally you can use the data mobility capabilities of the storage to move the snapshot in another region. Then you can recreate the volume snapshot
pick it back up
and pick it up, but then you use that primarily to create a replica. So it all depends on your RPO, RTO. So if you want to restore quickly, you already have an active Kubernetes cluster in another region with a replica of Postgres that is using it's called write-ahead log to continuously replicate the changes that happen on the primary. So it's pretty much aligned with the primary. So by default, with Cloud Native PG and Postgres, you get maximum RPO of 5 minutes out of the box across regions, which is not bad.
No, that's not bad. And I think for when you're talking about very large databases, right? 4.5. Why'd you pick 4.5? Is that just it's big enough?
I wanted to address at least more than a terabyte. But I've seen a pattern that basically there's fixed costs. I use Amazon in that case when you create snapshots. And then it depends. You get incremental and differential backup out of the box with most storage classes. So it shouldn't change much with the size of the database. Also because once we add in the next month support for table spaces, imagine this. Normally you partition by time. So you have the current table that can go in a volume that is very efficient with high IOPS. And then, the back you go in time, you use maybe a cheaper storage. But that data doesn't change. So you can get, I was talking about, 60, 100 terabyte databases with the customer before. Those tables don't change. So incremental and differential backup basically only operate on the deltas in the active tables.
Just
so
what's
once
been written.
we got table spaces, you could also parallelize the backup and the recovery of each table space. So I'm hoping to talk about these in Paris.
That'll be fun. I know that this is sort of something I think we've had to adapt to, because early days when we talked about Kubernetes and microservices and containers, I think a lot of people envisioned, okay, each service that a team is working on will have a small database, right? But the reality was people didn't use Kubernetes that way, right? That's unintended consequences of people saying, well, this is a system, I want to just move my giant database over here, right? So I feel like we've had to make an audible a little bit as a community to make sure to support these types of use cases better too.
It's actually interesting because I'm actually an advocate for microservice database. So normally it's a DBA that, because historically it was heavy to create a Postgres cluster. Okay? So administrators didn't want to spend time creating more Postgres clusters. So what happened? You had a gigantic instance with many databases. So we actually have a way in Cloud Native PG to import each database as a microservice in a separate Postgres instance, so that they can be independent. And this is good for GitOps operations, or to give responsibility back to developers that can own the database as part of their application. But it really depends on your organization, the skills you have in your organizations. It's really up to you to decide the way you want to use it. We recommend having one database per instance. and but then you can bring the monolith database back into Kubernetes.
Right.
With all, I think it's not the way I would like to move.
Again, going back to architecture, right? You really got to think through that. Well, hopefully we can link to maybe some documents or something that you have.
I'll share the blog article. I think you just need to look for Postgres Kubernetes architecture, and that should come.
You'll be top of the frame there.
I bet it's in the first three. If it's not, I'll pay you a beer.
Nice. Well, before we have to run here, I'd love to get your thoughts on sort of how you think this KubeCon is going. Is there any themes you've been seeing, or any light bulbs that you're going back to your day job and saying, like, here's what people are thinking about? I'm curious.
Yeah, man. Every time I come to KubeCon, it's overwhelming. It's amazing to see so many people, and transparency, and really joy to be part of this community.
Yeah.
So I think this is primarily what I like the most. It's to be part of a community, global community that is inclusive.
Yeah.
And having being part of the Postgres community since the early days, to me it's like a second life.
Okay.
And with the experience that we have matured 15 years ago when we started the Postgres community, but here it's to another level. So, but in terms of themes, I'd like to still think about data, because I think I see the data is becoming more and more present, also because of the AI theme.
Sure.
But if you want to do AI, you still need data.
You still need to pull from some source, right?
So I think I'm really happy to see data being more present, even in the talks.
Yeah, especially to the Kubernetes community in general. So I think we've come a long way with data on Kubernetes. So
and tomorrow there's a panel.
Perfect.
At KubeCon. So.
We'll make sure to link to all of these, the panels, your talks. I don't know when they get published and that kind of thing. We'll make them available for anyone who's listening and wants to see more Gabriele. He's a great ambassador. We need more people like you. I will say that in the community. Well, I just wanted to again thank you for coming on this show for this short little stint here, and enjoy the rest of KubeCon.
Yeah, you too. Thank you.